Hey, welcome back. This video I added text random into my UI library. The UI manager you see here, and here is my mirror main. This is for my committing. But now for UI manager. If you click this button, you're gonna see the window up here, and we're gonna render UI as well, and we render here a text widget. The text doesn't fit on the widget, so that's kind of an issue. If you just recalculate in the head, then not. But that's the issue for the future, and you can just drag it around. You can also resize. You can just do this. It's around 60 FPS. It's pretty simple how this works. First of all, we have our font manager. That's this thing. Now, your font manager here, we basically have a function that renders text, and that you give a string to it. It takes each chart that string walks through it. It renders each chart, and then it puts it like on a list for the string you've given it. Then it renders a line, and then it puts it on an image, and that image is put into with the grid packer. That packs it into a grid like on a large image. It puts that on the large image it's put on, and then you have it on the image. The image now has it. So and then that image is in the renderer sent to the shader. If we go to the renderer, then we can see that if we go to Control F U text atlas here, like if we go to this thing and then we go to the one below it, here we send it each time we send it to the shader. We send it. And the text atlas then sends the shader. We need to each time it changes, we need to deep copy it. We deep copy it and set set the texture of the U text atlas equal to that thing, and that's really useful. So then we do that thing each time, and then we all have text boxes. Those are basically the size and like around the texture of a box. The size of that are the 4 points of the text box. It's top, bottom, left, and right basically. So the minimum on the x-axis and y-axis, like the maximum on the y and x-axis. And those get uploaded to the GPU as well in an SSBO. Like basically the way to send an array from the CPU to the GPU. If we then go to our most important shader, our fragment shader, and here we first on the top we do an SSBO access, and this thing is bound to 11. It's just basically you have several slots, like each array has a number, and that number you upload it. You give it a number on the CPU side, and you can retrieve it with that same number on the GPU side. So in this case 11. And you have an inverse, and you can see here you can interpret it's basically any type, any memory type. We just use an I vector. That's IVEC4. It's basically a vector of integers for long, and then we basically step through in the vertex version here. We construct our widget. Our widget contains all the data we eventually need to render it in the next step. And it also contains our text ID. So if we go to here, we first check here, widget.textID is not equal to -1. -1 is always the nothing. Like if something says -1, then it is not a thing to be worried about, because text IDs can't be negative. That wouldn't matter anyway. So we just decided that can just be negative. Well, the next step is we get that text ID from text ID is equal to widget text ID. The next step, then we get our I vector or text box. This is the box around the text, and that's the text ID. The text box basically represents where it is in the larger image. So what we do in the next one, we get a pixel position of x and y. How do we do this? Well, our box is sort of located on the larger image, so you just so we first need to shift it by the text box 0. That's the first place in the array. When you look at that point, you have basically that point. That's the x0, and so you add the point in which you are in the text box to it. Then you get get it on the whole bigger image. The same we do for Y. Well, how do we compute it? We have another widget. Well, we have more fractals. And that's an integer. That's basically where they are on the whole screen. That's an integer for which position you have on your whole display. And this is just in floating point, but it's always like if 1080p screen is like from 0 to 1080p. And so we subtract then our widget dot plus 1 dot x from it. That's basically where does our widget start? Where's the starting point of our widget? And that starting point we subtract from it, and so then the difference is the position. The difference is the position, how far we in our widget. This shouldn't have to be negative. While we do the same, then we get our false color. This is basically the color of your widget. Your widget you give your widget a color, and you basically that's also got passed in fine SSBO, but that's gotten in the fragment channel and put inside your widget. Your widget has a color. The widget's worked, and this side we get that one. And what we do is we declare the color 255, and here we call and the C. This is a function that takes the color and puts it into 0 to 1 from 0 to 255, and that's basically it. And that's included from the widget builder, and that's a include system I've made. OpenGL normally doesn't do that, so it works. That's great. The next step is basically we get the float p in this case. Really the best name, but that's a get from a text fetch. You get to the text and say, I want to fetch this thing. First of all, you see here from this thing is text fetch. You see here the text atlas. We've seen that earlier. That's a texture upload, and so that name must be the same as the sampler. So that name is exactly the same as you upload it here, and then you have text atlas is the next step. And then we have the I vector. This I vector is the position at which we grab P or the color. Here we just grab P or the color, and we nab it. And that P is just very, 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 very useful. Because this basically says, well, hey, this is the multiplier to give, like the multiplier for the A-list increase. And the A-list, you have a range between 0 and 35, which color it is. Well, 0 and 1, and because it's already got set to normal coordinates. Normal coordinates, and the great part is that this is basically a texture. And this texture we only sent a grayscale, so we do .r, so we only get the first band. R means red, but in this case it's only the first like band of the texture we actually want to get. And below we say, hey, with the color we multiply each individual thing of our vector 4 by p, by this value, by this scalar. And so then you get the actual color, and that's no longer the scalar, and that's so you render your color. Your color is basically, and so you anti-alias your color, because if you multiply everything by p, there's just a change in the total result. You say there's just p just changes the whole result and anti-aliases it, and so you basically get get this image. Here you can see it outside. Here it is p finding p of 0, and so everything's set to 0. And that means that alpha is also 0, and so it is see-through instead of being just a solid color around it. Well, solid color around it, but the widget goes into here. This S is cut off, and you go around. That goes around it. It's cut off there because that's where the widget ends. So text doesn't actually fit in the again, and that's really great. And well, how would you want to set text though? Well, if you go to the UI manager, we can go here. We can go down here, eventually here. This is the place you set the text. And if I were to write ty in here and then run it again, then we see ATY. And this is the change text we have gotten. This is the actual text rendering. This is actually the text, and it just has a standard font. This font can actually be changed in the UI library. That's made for later, but now this is basically rendering text with the UI library. Also, it just looks insanely cool. This also is not really cut off because as it's wider, you also see that you have different widths and that it doesn't just base them on the width. And I don't know, like it has a advanced and LHB. You need to place the left and the advanced how much you go to the right. Anyway, that's beside the point. What we also can do is just say, well, this is no longer text. So we remove it, and if we then run it, then you see a white widget because of the colors. Because of the colors, and then we can of course, let's say this is 25, we can again run it and we get yellow because that's the end result of this color of yellow. That's the end result of that relationship. And so we have now three important things. We can have solid colors, we can have a image, a texture, and we can have text around it. Those are the three things we can do in the UI library, and that's enough for now. Well, that's until we get to the next step. That's input. Input is going to be with keyboard and mouse first, and that's well for the future. So, thank you for watching. Like and subscribe. Until the next time.